Today we're going to start Chapter 9 and we're going to do Section 9.1. Our goal here is to evaluate and approximate square roots and solve a quadratic equation by finding some square roots. Now before we do that, I'd like for you to look to the left of your note page and let's identify some terminology and some symbols. This is called a square root symbol. Well, we say a square root symbol because if there's nothing in this caret here, then that means we're undoing a square. If there were a number in the caret or the radical symbol, like a 3, then we would be undoing a cube. This would be a cube root. Okay, now if you look down here in this diagram, here is my radical symbol that I referred to as a caret, but it really is a radical symbol. The number on the inside of the symbol is called the radicand, and the number on the outside inside the little v or caret is called the index. This expression right here says, let's find the cube root of 8. In other words, what number would I cube to get 8? And that number would be equal to 2. Okay, because what is 2 cubed? 2 cubed is 2 times 2 times 2, which is 8. Okay, but our focus for section 9.1 is just primarily undoing squares, which we'll refer to as square roots. Okay, now let's look at simplifying radical expressions, and I want you to notice that we're talking about expressions right now only. Because we're looking at expressions, we are to give one answer, and the one answer is called my one root. Perfect squares are numbers whose roots or square roots are integers or quotients of integers. If you look at this problem here, this is a square root of 144. And what number squared gives me 144? Well, that number is 12. This is a positive answer called the primary or the principal root. It is a positive square root. Versus if you look at the problem below, we have a negative or a minus sign in front of this square root of 144. So this is a negative square root. It is called our secondary root. So our answer would be negative 12 and not positive 12 up above. And this is how we respond to expressions only. So depending on if your expression is positive or negative, that'll determine your one root answer if it's positive or negative. Now by definition up here it says the square roots are integers or quotients of integers. So if you look at the answer 12 as a quotient, we can say 12 is the same as 12 over 1, or we can do 24 over 2, etc. Any kind of quotient that is equivalent to 12. Down here we could do like negative 36 over 3, or we could do negative 48 over 4. So these are quotients of two integers. Sorry about my handwriting. My writing tool device is not working. So let's go ahead and move down to this next statement. If you look at the square root of 2, it is already in a simplest form. There is no number that I square to get 2. So therefore, this is the finalist, simplest form I could give this answer. And since it's not a quotient of two integers, this is called an irrational number. So a number that's in its simplest radical form that cannot be shown as a quotient or fraction of two integers, which would be rational, this is called irrational. An irrational number is a number that cannot be written as the quotient of two integers. Okay, now let's look at example 1 and start simplifying some of these expressions. Here you have some examples. If you look at the square root of 81, this is an expression, so I'm looking at one root. This is a positive, so I want the positive square root, which that would be equal to positive 9. In part B, I see a negative sign in front of the square root of 49. So I want a negative root. This is my secondary root. So my answer is negative 7. Now look at C. We've got this new symbol here. It looks like a plus sign over a minus. And how we read that is the plus or minus square root of 1600ths. So when I see plus or minus in front of the root, that's indicating give me both roots. Give me the primary root and give me the secondary root. Give me both the positive and the negative square roots. And you can either write it like this, like they've shown, plus or minus 4/10, or you could put 4/10 and you could do negative 4/10 if you wanted to. Either way is fine. Now let's look at D. D has a square root and a -1. Well, what number can I square to give me a -1? Well, there is no number that you can square to get a negative. So for our purposes this far, we say undefined. In other words, there are no real square roots. You will learn later that the square root of -1 is really an imaginary number. And I think we talked a little about that one day I had that t-shirt on that had the square root of -1. But what we're going to say is there are no real square roots. Okay, let's practice this number 1. And you can go ahead and use your calculator. And if you want to pause the video and come back, you may do so. I'm going to go ahead and pause the video and we'll move on to the next slide. Okay, so if we're looking at these answers, the square root of 9/100ths, what number do I square to get 9/100ths? Well, I know the square root of 9 is 3, but 3 squared doesn't give me 9/100ths. 3/10, well, 3/10 squared would give me 9/100ths. And notice that it has a positive, there's no symbol in here, no negative symbol. So this is indicating a positive or a primary root, 3/10. Here's another positive root. So the square root of 36 is just +6. The negative square root of 25 is -5. And the positive and negative square root of 100 plus or minus, that would be 10. Okay, the next thing I want to do is have you practice doing some calculator practice. In your book on page 508, let's look at some of these numbers. I'll go ahead and pause the video and go to the next slide. That gives you a chance to find your calculators and we'll practice a couple problems together.